given a 4-element array, all right, yeah, so we know x1 less than x2, x3 less than x4, okay? How many more comparisons do you need to find the second largest? Okay, yeah, all right. Second largest, it is relatively hard, right? Yeah. So then our thinking method is like this. Can we reduce the difficulty a little bit? Can we change it to the largest? Yeah. So let's consider find the largest first. Okay. Yeah. Find the largest should be easier, right? Yeah. So let's just modify this question slightly. Find the largest. How many more comparisons do you need? Okay. Yeah. Because we already know x2 is greater than x1, x4 is greater than x3. That means x1 cannot be the largest, right? x3 cannot be the largest, right? Yeah, so here we use the elimination method. Elimination method. By elimination method, yeah, x1, x3 cannot be the largest. Only x2 and x4 could be the largest, right? Yeah. So after we eliminate x1 and x3, so we only need to compare x2 and x4 to find the largest. Yeah, so that's the first step. So one comparison, we can find the largest, the first step. Then, after you know the largest, the second step, how to find the second largest. Yeah. So the first step, find the largest. Second step, find the second largest. Okay, all right. Yeah. But the second step should be based on the first step. You should use the result from the first step. Okay, yeah. First step, because the larger one of x2 and x4 should be the largest. How about we assume one is greater than the other one, right? Yeah. Because one is greater than the other one, can we assume x2 less than x4? Okay, yeah. Yeah. Because if x2 greater than x4, we just, we use the same logic thinking, we just, switch. Yeah. But to have a little more certainty, yeah, so we make this assumption. Okay, yeah, that means x4 is the largest. Okay, yeah, x4 is the largest. All right, now to find the second largest. How to find the second largest? Second largest, let us try to interpret what's the meaning of the second largest. What's the meaning of second largest? First, it is smaller than the largest. Yeah, no question. But if we take away the largest, then second largest becomes the remaining largest. How about that view? Simple view, right? Obvious. Obvious, simple view. That means after we take away x4, the second largest means the largest among x1, x2, x3. How about that? Okay, yeah. So the second largest means the largest in these three elements, x1, x2, x3, right? Yeah. All right. So now, because you have three equalities, number one equality, number two equality, number three equality, right? All right. Yeah, with these three, how many more comparison do you need to find the largest among these three elements? Right? Think about that. Okay? Yeah. The largest among the three, we can use the elimination method here, right? Yeah. If one element cannot be the largest, we can eliminate it, right? Think about that. Okay? Look at the first inequality, x1 less than x2. Can x1 be the largest? Because x2 is greater than x1. How can x1 be the largest among the three, right? So if x1 cannot, we just eliminate x1. Then in the remaining x2, x3, how many more comparisons do you need to find the largest? Think about that. How many more comparisons do you need to find the largest? All right, think about that. Okay, yeah. So the largest, you need one comparison. Second largest, think about that. Yeah, the answer is pretty much there. Yeah, but you need to get this kind of understanding straight. All right, the whole logical reasoning, get it straight. Yeah. Then the answer is there. All right, think about that. All right, so that's this question. What is the next question? Number 12. Yeah. Question number 5. Plug in values in calculator. Oh, all right. So let me just use the natural order. How about that? So Lie question number 12 next. Nami question number 5 after that. All right. So you just type your question in the chat area. I just follow the natural order, one after, first come, first serve, all right, in that order. So next one, Lee is question number 12. All right, given an array with 10 elements, what is the maximum number of inversions that array can have? All right, yeah. So here, I just give you a hint about the, how do you solve this problem, right? The general thinking method, yeah. All right, our goal, we need to solve the problem with n elements here, n equals 10, okay? All right. But when n equals 10, this question a little harder, right? Yeah. So one method we frequently used in this class, so that is reduce the difficulty by reducing the size. Okay, so that n size, if we reduce it, yeah, then it should be easier, right? Yeah, all right. So maximum number of inversions. Let's consider n equals 3. Okay, it's a small number. So when we consider, these 3, n equals 3, let's consider array with value 1, 2, 3. How about that? 1, 2, 3, we want to get the maximum number of inversions. Okay, yeah. Inversion, I believe you know the meaning of inversion, right? Yeah, meaning of inversion. Yeah. All right. Look at the array. If this array, if we arrange in this way, let's say 3, 2, 1. How many inversions do we have? Okay. 3, 2 is 1 inversion, right? Inversion number 1. 3, 1 is inversion number 2, right? Okay. 2, 1 is inversion number 3, right? Yeah. So is this the maximum? Think about that. Is this the maximum? Yeah. Because here, let's look at this way. Select any 2 pair of elements, it is an inversion, right? Yeah. Because you select any 2 elements in the array, they form an inversion. Any 2 elements in the array, they form an inversion. Any 2 elements in the array, they form an inversion. That must be maximum, right? How can you get more than that? Think about that. Yeah. Right? So with this understanding, now you go to n equals 10. Can you find some rule you can extend it to n equals 10? Look at that. Yeah. Given 10 elements, okay? Yeah. You just try to find a way. Select any 2 elements in the array, they form an element, an inversion. Any 2 arbitrary 2 elements in the array, they form an inversion. That must be maximum, right? Yeah. Yeah. So look at that. All right. Yeah. Because if you are not quite sure, you can consider n equals 4, 5 to, build up a little more confidence. After you are pretty sure your conclusion is correct, so at the end, you consider n equals 10. Okay? N equals 10. Yeah. From 3, it's easy to understand, right? Yeah. Maximum number inversion. Then gradually, you increase that size number, and at the end, you can see the answer for n equals 10. But you need to observe some special rule. Yeah. Based on this kind of experiments, you can find some rule. Yeah. The rule is not that hard to find. Okay, yeah. All right, yeah, so that's question number 12. All right. Question number 5, yeah. I talked about that before, yeah, but here, all right, yeah. So you can see my handwriting is still here, yeah. For Nomi's question, we just plug in calculator and compare. Yeah. Here, all right. So calculator or not, yeah. For me, I like you to do it without calculator, yeah. But if you really like to use calculator, I cannot stop you, right? Yeah, I cannot stop you. But the calculator, it may not be the regular calculator, right? If you use your, on your cell phone, you have that kind of calculator, probably it's too weak, right? Yeah. So you may need a little more powerful calculator, like I use Wolfram Alpha. Any of you heard of that? Wolfram Alpha. Yeah, I can show you there. See, Wolfram Alpha. All right. Yeah, this scientific, calculator, including symbolic calculation, much more powerful. You can use that if you need it. Yeah, but for this question, you do not have to. Without using calculator, can you find expression? Right? For example, this log base 10 here. N is 10 to certain exponent number, right? Log base 10 to certain exponent number. That is pretty easy, right? Yeah, look at that. All right, so suppose M equals 10 to the, let me just write X. All right, then log base 10 of N just equals that X part. Okay, so the first expression, you can write it out immediately. Yeah, not that hard, right? For me, even easier than I using calculator, because calculator, I need to enter that X 10 to the 10. So you need to type 10 0 to the exponent. All right, although you can do that. Yeah. If you like, you can do that. Yeah. So then the second one, if you use the basic property, yeah. All right. Do you know? So let me just write the property. A to the N to the M. Okay. Yeah. Do you know it equals A to the N times M, this property? Use this property to simplify. Okay. Yeah. For B, we'll plug in, keep using the property like this, okay, to simplify. So then you can compare, okay? Then you can compare two expressions, which one is larger, which one is smaller, okay? Yeah, but here, you make your decision if you want to use calculator or not. I do not stop you using calculator. Yeah. Okay. Yeah. But my personal preference, I like everyone just use the hand calculation. Yeah. You use the, algebra formulas, properties to do the simplification. That's my, personal preference. Yeah. But if you want to use the calculator, I just like to use the in the right way. Okay, right way. Yeah. All right. Yeah, because when you enter exponent number, yeah. So in the calculator, how do you enter that exponent number, right? Yeah. So you need to find it out. Yeah. All right. Yeah. So that's question number 5. Question number 25. Question number 25. Last question. Last question. All right. Yeah. Look at the last question. One thing it's different from all the other questions. Here, do you see solution here? All the other questions, you see answers. Answer. answer word, then this one you see solution. Solution, you are expected to provide details, not just one answer, all right? If one answer, you can only earn partial credit. Right? You need to give me the main steps. Let me know how do you find your answer. At least a few important steps. Yeah. So I can see you get an answer not by guess, no, by logical reasoning. Okay, yeah. Then you can get full credit. Okay, yeah. For other questions, although you only need to give me the answer, but to earn partial credit, okay, partial credit, okay, you better give me main formula or steps. All right, yeah. Because in that way, even your answer is wrong, but your method is correct. I just look at, how do you get the answer? Yeah. The purpose is if you write some of the, just a little more information, okay? If I see it is related, okay? So your work is related, yeah, basically correct, okay? I will give you partial credit. Otherwise, one answer, one number, true or false, correct, you get full credit. Incorrect, you get 0. So think about that. So you can improve your chance by, writing a little more to earn partial credit. That's for the answer case, all right? Yeah, yeah. For the solution case, you are required to provide the details, all right? Yeah, details. All right, okay. All right, so here for the question, yeah, let me give you some idea here. Yeah. Given 2 ordered arrays, already ordered, yeah, do not ignore this information. That's first, okay, yeah, because I write it out, okay, you won't miss it, okay, yeah, this means ordered, okay, yeah, all right. We want to find the median of these 6 elements. That means the third smallest element of all, and assume that all the elements are distinct. After we do the first comparison, A2 and B2, and we get A2 less than B2. What are those elements that cannot be eliminated? Can be eliminated from the consideration as the median. Yeah, all right. So here, the median, we know in the question, you're already given median is the third smallest element, all right? Yeah, but at the same time, yeah, so let me draw a simple diagram here. We have 6 elements, 1, 2, 3, all right, total 6, yeah. Assume if they are finally ordered in this way, the median third smallest, right? This one, okay, yeah. But this way you count from the left, it is the third smallest. How about if you count from the right hand, from the right, okay? That will be the fourth largest, right? That will be the fourth largest. Okay, yeah. So you look, you understand this median in two ways, either the third smallest or fourth largest. Okay, yeah. The reason you look at from these two directions, then you have a chance to eliminate more elements. So here the strategy okay, try to eliminate as many elements as possible. Yeah, as many elements as possible. Okay. All right. Yeah. So that's the, general idea. Yeah. All right. To be more specific, let me just, push my hand a little more forward a little bit. Then that's all I can do here. Okay. Yeah. Just a little more specific here. All right. How to implement the strategy? Here the question is. Yeah. So we know we want to eliminate as many as possible. The question is how to implement. Sorry. Implement this strategy. Okay. Here, let me give you two concrete steps to implement this strategy. Okay. Yeah. Two concrete steps. Okay. All right. Step one. All right. Yeah. Step one is based on our observation. The median must be third smallest. All right. Yeah. So then it means, so based on that, if so look at that. Okay. Yeah. Third small. Yeah, I want to erase it. I want to. Oh, yeah, yeah. So the software, not that good. Too slow. Yeah. Why so slow? All right. All right. Yeah. Third smallest. Okay. All right. So then I just interpret this third smallest. All right. So let me write this sentence. If all right. So okay. Yeah. Yeah. Let me use okay. Yeah. We consider the current element as X. Okay, as X. Yeah. If there are more than two elements smaller than X. Okay. Yeah. So can you find, based on the given information? Yeah, the given information already there after first comparison. If you look at the current X, the X could be anyone in A1, A2, A3, B1, B2, B3, right? Could be anyone, okay? Yeah. So you consider each one, okay? X could be each one, all right? If by the given information, you can find there are more than 2 elements smaller than X, then your conclusion is X cannot be the median, right? That's how we interpret third smallest, okay? Third smallest, that means there are exactly 2 elements smaller than that one, right? But here you find more than 2 elements smaller than X, then X cannot be the median, all right? So that's the first implementation step. Yeah, here we are working on implementation of the strategy. The second implementation step, we use the fourth largest view, okay? This time we use fourth largest view. The largest, that means there are three elements greater than X, right? So look at that. If there are more than 3 elements greater than X, then your conclusion is X cannot be the median, right? From 2 directions. So you increase your chances, okay? Yeah. From the left, from the right, examine how many elements are smaller than that one. How about that? Okay. Yeah. All right. Yeah. Let me save. Yeah. So my handwriting on this document, probably you like to have it, right? So after this meeting, I post this PDF file. Yeah, this is a PDF file, okay? Yeah, so I post it. So when you work, so you can see closely this document. Yeah, yeah. All right. Next one, now question number 6. All right, okay. Yeah, so here we're at question number 6. All right. Which of the following growth functions has the lowest order of growth? Yeah. All right. To do that comparison, yeah, here I just give you a few basic points. Yeah. That kind of thing work for both question 6 and question 7. Yeah, similar. Yeah, similar questions. So we can, put them together. Yeah, we can discuss these 2 questions together. All right. I like to point out, 2 basic facts we have learned, yeah, in our class. Yeah, here just, refresh your memory a little bit. Yeah. All right. The first thing is, the first fact is the order of growth, this concept for the power function power function. Yeah. So what's the power function? N to the dth power. N is the variable. Okay. N is the variable. D is constant. Constant variable. And so for the power function, the order of growth, that is just the exponent D. Okay. Yeah. That's the easiest case. Yeah. This power function is the easiest case. Easiest. All right. So that's usually we use power function to be our G function. Yeah. So we have F function, G function. G function, we want to make it as simple as possible. F function could be more complicated. So the G function, usually we like to use the power function to, to see the order of growth easily. Okay, all right. But that is for the power function. Okay, yeah. But then some functions, it is very hard to use some specific number, order of growth, that number to measure. Okay, yeah. So the second, yeah, there are two functions. Yeah. One is the log function. Okay. Log function, log any base. Yeah, the base could be a and yeah, a greater than 1. All right, yeah, okay, yeah. And another one, exponent function, x a to the n. Okay, a to the n, exponent function, and a also greater than 1. Okay, yeah. These two cases, yeah, it's hard to use specific order of growth number to measure. Yeah, all right. But these two functions, we have the limits. Now, in our notes, I did 2 examples. So those 2 examples can be used here. Yeah, because here we have exponential function. We have log function, right? Yeah. So we need to be familiar with these 2 functions. Yeah. In our notes, we have these 2 results. You can use these 2 results. You can use to help you solve these 2 questions. You know, what are those 2? Yeah. One is limit when n goes to infinity. Yeah. N to the dth power over a to the n, its limit is 0. Okay, for any positive d. Okay, no matter how large it is. So that is one result. That means the exponential function has higher order of growth than any power function, right? Yep. Because the limit equals 0. The denominator should have higher, order of growth. All right. Another limit that is useful here, the limit n go infinity, the log function, any base over n to the d also equal to 0. Okay? Yeah. So the second one, even this d is a very small number. Look at that. Here, the d is small, right? D equals 0.00001. Even you take that small, the log function over n to the dth power, its limit when n goes to infinity, it is still 0. Look at that. Okay, so these 2 results really help us to make our decision which function has higher order of growth. Higher order of growth. Okay, all right. So one more thing, yeah, when you consider this case, only look at the dominant term. You can ignore the minor terms. Dominant term, n squared, then you take square root. So you can get a very simple expression. All right. All right, so for this one, how do you look at the order of growth in that one? Think about that. All right, yep. So here, can you get something from this limit? The second limit, okay? Does the second limit help you find the answer a little bit? When you look at C, second, help you a little bit? Think about that. All right, yeah. So when you look at each term, use the fact here, all right? Use the fact here to do the comparison, okay? To do the comparison, yeah. Yeah. If you have further questions, just ask me. I will make more explanation, yeah. Here, I feel, based on the information here, you should be able to find your answers. Okay. All right. Yeah. So if you feel, so I couldn't get it. Yeah. So you can keep asking me questions. All right. Yeah. Next one, number 13. All right. Unordered array n greater than 2. It is known that there are total k elements in this array that are not in place. Not, okay? Yeah. Not in place. What is the minimum number of k? Okay, minimum number of k. All right. So I will go find the minimum number of k. First, we know k must be greater than 0, right? K cannot be 0. If k equals 0, then it means ordered, right? Ordered, but we are given unordered. Yeah. Unordered, it means at least one element not in place. Yeah. Because if all the elements are in place, then the array is ordered. Okay, yeah. So here the basic fact is, if all the elements are in place, then the array is ordered. Okay, yeah, but our assumption unordered. All right, yeah. Okay, yeah. So k must be greater than 0. Then next one, the question: is it possible that k equal to 1? So next question is it possible that k equals 1? All right. The question is, if k equals 1, that means there is only one element not in place. Okay, k equals 1. That means there is exactly one element not in place. Okay, in other words, there are n minus 1 elements in place. right? Yeah, because there are total n elements, n minus 1 elements in place. Is it possible? Look at that, n minus 1 elements in place. Yeah. So you arrange, you have n elements, you make n minus 1 elements in place. Then the remaining one has no choice, right? The remaining one has only one position to go. That position not in place. Think about that. Yeah. N minus 1 elements all in place. The last element, only one position to go. That position, do you think in place or not? Look at that observation. All right. After that, then, you know, you try to get your answer. Okay. Yeah. That's already, you know, halfway to find your answer. Halfway to find your answer. Okay. So then you try a little more, then you will get your answer. Okay. Yeah. How about that? Yeah. So after you get the answer of this question, is it possible? Yeah. Then you're pretty much halfway there. All right. Halfway there. All right. Yeah. That is question number 13. Okay. Number 10, next one. Number 10. Oh, yeah, this one, you know, pretty tricky. Yeah. All right. So this one, the goal to find appropriate integer a and integer b such that this fractional expression equals a phi plus b. Okay, all right. To do that, to solve it, use our two properties for the golden ratio. One is right, the other is okay. Yeah, these two properties. All right. All right. And the question, when you start, you try to use one of the two properties in the right way. Okay, in the right way. All right. Yeah. So here, there are many ways try to transform the numerator. Many ways to try to translate the numerator. Okay. Yeah. Yeah. For example, phi cube, one can write phi times phi square. Okay. Phi square, you can use second property. That's one way. Another way, some students, when they see phi cube plus 1, they apply the formula phi plus 1 equals phi square minus phi plus 1. Yeah. In that way, they can, you know, use phi square, you know, plug in, replace to do simplification. Yeah. Yeah. But after you do some, you know, transformation using these two properties, can you you know, make the denominator 1? Yeah. So that means a lot of things cancel out. Think about that. A lot of things cancel out. Can you? Yeah, because our goal here, the denominator is gone, right? A phi plus b over 1. Can you, you know, your transformation finally make the denominator equal to 1. Is it possible? Yeah. Try that. Yeah. Okay. Yeah. The answer is possible. Yeah. You can do that. Yeah. You, after the manipulation, you can get there. All right. You can get there. All right. You know, yeah. Just sometimes use the first property, sometimes use the second property. All right. Yeah. Just a few times. Yeah. But the way to use these properties, you need to work carefully. Okay. Yeah. And try your best. Yeah. Yeah, we know when we do algebra, sometimes you need to find the right way. Okay, after some experiments on your scratch paper, try several different ways. Yeah. One way should work. Yeah. One way should work. Okay. All right. Right. Yeah. For the Sylvia's question, you only consider positive. Yeah. Golden ratio phi. Yeah. Do not consider negative. Negative we do not call the golden ratio. All right. Yeah. 1 plus root 5 over 2. Yeah. Yeah. Some students plug in number. I do not recommend that way. I do not recommend, but if you really, because I cannot stop you to do that, right? Yeah, because it's not a smart way. The reason I do not recommend you, it's not a smart way, right? We like to do it in a smart way. But if you try to, your goal is find an answer, you don't mind trying some dumb way, right? If you plug in, so that's fine. Yeah, you can try, but your goal is, find the correct answer. All right. Yeah. Emily, number 22. Yeah, I do not skip your question. Yeah. I mean, I just, because here we are talking about the golden ratio, I just answer Sylvia's question. Now I get to your question, number 22. Yeah, this question also a little challenging. Yeah, so let me give you a hint. Yeah, make sure you find the answer. The first hint, yeah, the first hint part 1. Okay, hint part 1. Okay, all right. Sort 4-element array. 4. All right. 4-element array. We did it in notes, right? You can find the whole solution in our notes. Yeah, I remember, in one of our lectures, the last topic I did, yeah, sort, yeah, go to the insertion sort. Yeah, I remember the insertion sort because sort 4-element array, it is related to the insertion sort. Go to the, the last topic in that insertion sort. Okay, insertion sort. You will see this one. Yeah. The reason I put it here is here, although 5-element array, but 1, x3 is the median. x3 is the median already. Yeah. You know the position of the median, right? You know the position of the median. If we write a diagram, yeah, 2 or 5 elements are sorted. Okay, yeah, and we know the median x3. It is known. Yeah, it is known, right? Yeah. All right. So look at that. Because the position of x3 is known. All right. Think about it. So if we ignore x3, we can ignore x3, right? Then the remaining 4 elements unordered, right? Remaining 4 elements unordered. So we need to sort that remaining 4 elements. But how to do it? Given in the notes, okay? Given in the notes. So you can sort remaining 4 elements using the method in our notes. You can find a solution. After that, can you put x3 back in place? After you sort remaining 4 elements, can you put x3 back in place? It is the median. You know where to put it, right? Where to put it. Yeah. You use that way to understand this question. How about that, Emily? How about that? Connect to sorting 4-element array. 4-element array. That's important. Yeah. Yeah. So you need a solution of that question. All right. So go back to find that answer. Then there is a small gap between that answer and this one. Small gap. That small gap is the x3 is the median. Can you fix this gap? This little gap? You can fix it. You know, this diagram show you how to fix the little gap. Okay, x3 median. You can take away, you can put it back. All right. Yeah. All right. Good. Okay. Yeah. So we used up 1 hour. Yeah. But so if any of you still have questions, I give you one more question. Last question to ask. If not, we just stop right here. How about that? Okay. If you still have a chance to ask final question. If not, that's all we have here. I will post this document. Yeah, you know, all my handwriting on this document. So probably it is useful for you. So I post. Oh, question number 15. Yeah, the last one, Nick. All right. Yeah, question number 15. 3-element array. How many comparisons do we need to find the median? All right. Yeah, here. Okay. Find the median. How many comparisons? Here, I just give you the hint. Work for the worst case. Okay. Work for the worst case. Do not work for the best case. Because if you work for the best case, you have not solved it. Only you work for the worst case, then because you solve the worst case. There is no other case that is worse than this one. All right, yeah, find the worst case. All right, 3-element array, because the number is so small, x1, x2, x3. Okay, x2, x3. All right. After first comparison, you get some information. After second comparison, you get some information, right? All right. Okay. All right. And oh, here I may point, yeah, another question related to this one. Still in our insertion sort. Lecture insertion sort that lecture. I sort 3-element array. Do you remember that? 3-element array. Before I sort 4-element array, I sort 3-element array. Yeah, all right, 3-element array. Because that's very easy. Insertion sort. Just use the insertion way. Yeah. So you know how many comparisons you need to sort 3-element array, right? Yeah. Find a median. But if you sort 3-element array, can you get a median? You already sorted the one in the middle. is the median, right? So the question is, you need to think about, can you use fewer comparisons than sorting? Yeah, because usually finding the median, we do not need that many comparisons as the sorting, because we only need to find the median. But for 3, it's a small number. There is a possibility you may not be able to use fewer number of comparisons. Yeah, so think about that. Yeah, sort 3-element array, that's the, that's the maximum number you can consider. Sort 3-element array. Yeah, let me a little more specific. Sort 3-element array, how many comparisons do we need? 3, right? Yeah. Look at that insertion sort. Insertion sort 2-element array, we need 1 comparison, right? But now the 3rd element to join the sorted array, we need 2 more comparison. 1 plus 2 equals 3. Okay. So by insertion sort, we need 3 comparisons to sort 3-element array. So next, to find a median, if we sort it first, we can get a median immediately. That means we can use 3 comparisons to find the median, but you need to go 1 more step. Is it possible to use 2 comparisons to find the median? For the worst case, all right? So you need to answer this question. Now, all right, let me write it here, the question. Is it possible to use 2 comparisons to find the median of 3? All right, is it possible to use 2 comparisons? If yes, your answer becomes 2, right? Because it is possible, right? If no, your answer is 3, all right? Yeah, so the question, if the answer is yes, okay, your answer equals 2. If the answer is no, your answer is 3. How about that? But here, when you answer this question, remember, for the worst case, not for the best case. Yeah, because sometimes some students work for the best case. Then they say, yes, no, it's not good enough. It must be for the worst case. All right? Yeah. If you consider all these things, then you can get the perfect answer here. Okay? Perfect answer. All right. Yep. Sorry, pretty messy. My handwriting here pretty messy. Yeah. Hope you can still, get useful information. Yeah. All right. All right. So can we stop right here? Yeah. Oh, regarding the last question, regarding the grace period, right? Grace period. Yeah. For some of the students, I mentioned a little bit, but for many of you, you may not notice that the grace period for, for this class, grace period. Okay. Grace period. Okay. Yeah. Usually I give 1 day grace period. Yeah. So 1 day. Yeah. So for example, if the deadline is Friday, then I allow you to turn in, the latest Saturday without penalty. Yeah. But for this assignment, I like to modify grace period slightly, try to encourage you to turn in as early as possible. So I will do this way. All right. I plan to do this way. Yeah, I will post it in the announcement. I just let you know here first. All right. If any of you turn in on Friday, yeah, so our original deadline, Friday, okay, I give you 4 points extra credit, okay? If you feel you are ready, I encourage you to turn in on Friday, tomorrow, so you can earn 4 points extra credit. Yeah. That means one question is worth 4 points. So you just, get the 4 points for, yeah. That means if you miss one question, so this one just to, fill in that hole, okay? Yeah, that's the Friday turning. The second one, Saturday turning. Okay, plus 2 points extra credit. You use one more day, so I reduce 4 points to 2 points. Yeah. Sunday, no penalty. Okay. Sunday, the student, I still allow, if student need more time, 0 extra credit, but no penalty. Okay. Still, for some students, still pretty good. Okay. Yeah. So the policy will be like this. Okay. Yeah. I will post in announcement, to make everyone, know this policy. Okay. Yeah. For you can make your plan based on this policy. Okay. All right. That's it. So that's all I need to tell you in this help session.